Hi, I'm Paul Kyogan from GK Tuition, and in this video I'm going to talk to you about probability. The question we're looking at here is 2018 Paper 2 Question 3. In the first part of the question, you're given a 6-digit security PIN code. Now straight away you should realize that we're talking about a permutation here. The order matters. If the order matters, it's a permutation as opposed to a combination. And the way you learned permutations in primary, not in primary school, at junior cert, was usually as boxes where you work out the number of options you have here, the number of options you have here, and so on. And I still think that in a lot of cases that's still the nicest way to do these questions. You're asked to find the number of, so in any one of these boxes you can put any digit between 0 and 9 inclusive. And you can repeat digits as much as you want. So you could have 9999999 if you want, okay? And for the first part of the question, the only condition we're given is that the last digit has to be a 0. And you're asked to work out how many possible combinations, 6-digit combinations, could you come up with using the digits 0 to 9. So always start with the box that has a condition. You've only got one option for that box. It has to be a 0. So there's only one option, so I put in a 1 in there. Now there's no more conditions, so it doesn't matter what order I do the rest of it in. I can put anything between 0 and 9 in here, but I can include 0 and 9. So there's 10 digits. Just think of your mobile phone. There's 10 digits altogether. 1 to 9 and 0 is 10. So you've 10 options there, you've 10 options there, you've 10 options there, 10 there, and 10 there. Obviously you want to pick this digit and that one, and that one, and that one. You have to pick them all, and it makes sense to put and in between them. And means multiply. So if you just multiply them by each other, it's 10 to the power of 5. So there's 100,000 possible combinations. In the second part here, we're asked to work out the number of combinations that will contain the digits 2018 and in that order. So they have to contain 2018 in that order. Okay? So now you have to realize that you should no longer view this as having 6 different digits. You need to view the digit 2018 as just one option. So let's look at this first. Like supposing we started off with the digits 2018. The first 4 digits were 2018. That means that the only options at the start would be 2018. But if you had 2018, then you've got 2 more options. In the next box, you still have 10 options, because remember, digits can repeat themselves. So you could have anything between 0 and 9, anything from 0 to 9 here. There's 10 options there, and you've 10 options there. So one possibility is that it starts off with 2018, and then the next 2 digits are whatever. You need this, so you need to multiply them. The number of possibilities that start off with 2018 is 1 by 10 by 10, which is 100. Okay, but obviously there's more. Obviously the 2018 doesn't have to be at the start, it could be in the middle. Another possibility is that 2018 goes in the middle. So there's only one option for the middle. It has to be a 2018, which means that here there's 10 options, and here there's 10 options. So there's a random digit, then there's 2018, then there's another random digit. And the number of possibilities there is 100 again. And obviously now the third possibility is that the first 2 digits are just random, but that the third digit, the last 4 digits are 2018. So this could be anything. This could be anything, but this has to be 2018. And the number of possibilities there is 100. So there's 100 possibilities that start off with 2018. There's 100 possibilities that have a 2018 in the middle and a digit either side of it. And then there's 100 possibilities that end in 2018 and have 2 digits before it. Now remember, so obviously either you're going to have this pin or that pin or that pin, and in probability or means that we add. So the total number of possibilities that have of 6-digit pin codes that have 2018 in them is 300. So your final answer there is just 300. Okay, before I look at part B now is relatively straightforward as long as you understand what your factorials are. This is just a quick rule that I want to run through with you. You will have to use this rule for every single induction question where you've got a factorial. So this rule is most important in induction, and this was the first time it came up in probability like this. So you should realize that 6 factorial is the same as 6 multiplied by 5 multiplied by 4 multiplied by 3 by 2 by 1. Another way of writing 6 by 5 by 4 by 3 by 2 by 1 is 6 multiplied by 5 factorial, because 5 factorial is just that bit. So really the rule we're using is that 6 factorial can be broken down to 6 by 5 factorial. 10 factorial could be broken down to 10 by 9 factorial. N plus 2 factorial could be broken down to n plus 2 by one number less than it. 1 less than n plus 2 is n plus 1 factorial. N plus 3 factorial becomes n plus 3 by n plus 2 by n plus 1 factorial. Now using that rule, this question becomes relatively straightforward. Algebraically, there's nothing we can really do with an n plus 1 factorial. So we want to get rid of all of our factorials. So the first thing you should do is, whatever are the larger numbers, you have to break them down to the smaller numbers. Clearly n plus 1 and n plus 1 are the smaller numbers here, so there's nothing, you don't do anything with the denominator, you leave it as it is. But on the top, I need to simplify n plus 3 factorial down to n plus 3 by n plus 2 by n plus 1 factorial. And I need to simplify n plus 2 factorial down to n plus 2 by n plus 1 factorial. That's handy for me now because that n plus 1 factorial will cancel with that one, and that one will cancel with that one. So on the next line now, it's just basic algebra of n plus 3 by n plus 2 by n plus 2. And if you multiply this out, now obviously I've skipped a few lines here, your final answer should end up as n cubed plus 7n squared plus 16n plus 12. Which means that a is equal to 1, the number in front of n cubed, b is equal to 7, the number in front of n squared, c equals 16, and d is equal to 12. So again, I think that this question was relatively straightforward if you knew your theory. So if there's anything you're unsure of there, again, make sure you let me know in class and I'll try and explain it differently for you.